diagram based. So let's analyze through the diagram. Both are of same length, the strings. Let me take two different strings so that we can recognize. So this is the bob. So when they come to the what is the state of them? The balls will have actually they're a bob. No, you treat like a point mass. To explain the problem, I had to show some shape. So therefore I just took that one. So they will have velocity. Both will have same velocity initially. U the length is L. So U should be equal to root GL. Root 2 GL. So this is the mass M small m. The collision is perfectly elastic. So after collision, what happens? So their velocities, they will rebound. I think, okay, what? Okay, there's a better diagram. Yeah. Collision is elastic, no? So will they have same speed or different speed after collision? So let me, different. So V1 and V2. If the ball of M reaches the maximum height, which is allowed, what is the maximum height allowed? Maximum height allowed is this one only. So there's a maximum height allowed. So the ratio of M by M can be. So we know initial velocity, they'll collide. Can it complete vertical circular path? I think it should be no. It is not something, it cannot come to rest here. So it should have some velocity. So what is that velocity? We know this velocity should be V4, I'll write it. So what is V4? V4 should be equal to all the calculation part, we'll see it. So this will be the circular path. Okay, V4 should be equal to root GL. Then V2 should be equal to root 5 GL. We should not assume it to be a test. That may think that one. So when V2 is root 5 GL, apply conservation of momentum. Mu minus small mu should be equal to M small m V2 minus capital M V1.
Why can't V4 be 0, sir? Said only maximum height. He didn't say
Vertical circular motion, can it come to rest here? Possible, huh? In vertical circular motion.
He didn't say vertical circular motion, sir. He said maximum height.
See, maximum height is only this is possible. Can it come to rest at this particular point? If it comes to rest here, anything, it will leave circular path in this region. If it can reach us here, means it must have some velocity. It cannot come to rest here, I feel. Okay, I'm just taking help of, I'm taking vertical circular motion. So is it possible this bob can be at rest at this point? So it must have some minimum velocity here. So this is the possible maximum height. So as it completes vertical circle, so therefore V4 should be equal to root GL. So V2, I know it is root 5 GL M V1. Okay, they'll collide elastically. There's the one equation. They collide elastically. Mu square, small mu square. MV1 square. Solving these two, I think the unknowns are this V1 I can replace solving for small m by capital M. Can you work out? Huh? There's the idea. You'll get the answer. Okay, two options are there. I don't know. Some. Which is allowed m by m can be allowed is telling a. So the 2 will get eliminated. So mu square will be 2gl m plus 2gl equal to m v1 square. V2 square we know it. V2 will be 5gl. So this will become m 2mgl minus 3mgl equal to mv1 square. Okay, no, let me call this as equation 2. Substituting for V1, V1 will be substitute 2 in 1 and solve for capital M by small m. Why that allowed is telling? So you see again the thing is allowed word is brought here.
Get greater than some values.
Yeah, this in fact it is